Okay, today we are going to see about verification of Ohm's law and Kirchhoff's law. Okay, this is the third experiment, but we are converting it into second experiment for today's class. The second experiment in the manual will be converted to third experiment. Okay, to do this experiment, first you need to know Ohm's law. You all know that. You know Kirchhoff's current law as well as voltage law. There is no problem in it. Okay. We will directly move into how to calculate the tabulation for verification of Ohm's law. Okay. Okay, this is the Ohm's law circuit given to you. What you need to do is the first tabulation you need to do is constant resistance and a variable voltage. Okay, constant resistance and variable voltage. Okay, this is the circuit diagram for verification of Ohm's law. Okay, this is the battery voltage and this is the resistance and this one is the ammeter. Okay, what you do is you need to assume a value, constant resistance value over here and a variable voltage value over here. Okay, for that what I'm going to do is here constant resistance I'm going to take it as okay 10 kilo ohm. All the values are 10 kilo ohms. Okay, all the values over here are 10 kilo ohms. And the variable voltage, what I'm going to do is I'm going to change the voltage as 10 volt, 20 volt, 30 volt, 40 volt, 50 volt, and then 60 volt. Okay, uh, we know we need to find the current which is flowing through this path. Okay, according to Ohm's law, you know that V is equal to IR. So, you know I is equal to V divided by R. So, for theoretical values, what you are going to do is use this formula, which is nothing but V by R. You know for the first one, V is 10 volt and the resistance is 10 kilo ohms. You see, kilo is there. So what you need to do is multiply the value by 1000. Okay, so what will be the value? 10 power minus 3 amperes. Okay, so write it over here 0.001 amperes. Okay, here it is written in milliamps. Don't worry, you put the unit over here as amperes. Okay, if you want to convert this into amperes, you have to multiply another 10 power minus 3. So the unit will be 10 power milliamperes. Okay, so I ask you to assume your resistance values. Okay, you can take resistance values such as 1 kilo ohm. Okay, you use a value of 1 kilo ohm for calculating the Ohm's law circuit for constant resistance and variable voltage and find all the values of theoretical value. Okay, use this voltage as it is. Okay, you can note this in your tabular column. Use 10, 20, 30, 40, 50, 60. Use resistance value as 1 kilo ohm for all your experiments. Okay, for Ohm's law. Okay, next what you're going to do is going to do this one. Okay, you are going to make a constant voltage but a variable resistance. Okay, you are going to choose a constant voltage but you are going to make the resistance as a variable. To do this one, what you do over here is choose a constant voltage of 10 volt for all the tables, for all the rows you choose 10 volt. Okay, then for variable resistances, what you're going to choose is start from 1 kilo ohm, 2 kilo ohm, 3 kilo ohm, 4 kilo ohm, 5 and then 6. Okay, then find all the values. Okay, same formula is applied. Formula is this one. For both the tabular columns, the formula is the same. Find the theoretical values. Okay, find all the theoretical values, apply the formula and find it. Okay, I will tell you what should be done for practical in the last step. Okay, you need to do practical using a multi-sim software, which is an online tool. So I will explain you about that one also. First, you do the theoretical value for Ohm's law. Next, you know how to do a Kirchhoff's law. Okay, you know how to make a Kirchhoff's law. For that, here is the manual. Okay, you print this manual. After doing all the calculation, put the values in the tabular column in your manual. There is a extra page in the manual for making calculation. You can split this page and put the calculation over here. And here is also model calculation space. Empty page will be given to make the calculations. Okay, for Kirchhoff's current law, this is the circuit diagram and this is the tabular column, and here you will be having a calculation space for you. This is the circuit. You see this circuit has two loops. Okay, this is the battery source and this one is another battery source, and you are having two resistances R1 R2 and similar resistance for the two loops R3 is there. Okay, you need to assume the resistance value and the battery value. Okay, what I'm saying is if your register number, all have your register number, take the last three digits of your register number. Okay, if your register number is somewhat, okay, you take last three digit as 101. Okay, and apply all the 101 for all the values. Okay, this is 101 ohms and this one is 101 ohms. Okay, and this one also 101 ohms and this one also 101 volt. Okay, apply all the values. Take the last three numbers of your register. Okay, so what you are going to do is do the Kirchhoff's current law. We have already seen this thing. Okay, assume three currents, two currents I1 and I2, which is flowing in the clockwise direction. Okay, from this you can form the equation 1, which is nothing but 101 will be equivalent to 101 plus 101, which is nothing but 201 I1, whereas the current I1 is flowing in this direction and the current I2 is in this direction. So what you get is minus 101 I2. Okay,
Sir,
this will be
202,
the
sir.
first equation.
202.
The second equation for the loop 2 will be, what you get is, here you see the current I2 is going from positive terminal of the battery towards the negative terminal of the battery. So you get minus 101 will be equivalent to 101 plus 101, which will be plus 202I2 and minus 101I1. Okay, which will be the second equation. Okay, so this one will be 2. Okay, 202I1, and here the second equation is formed. Use any one of the method, solve the equations and find I1, I2, and for I3 you know how to find this thing. As seen in the previous class, I have said the current I1 is from B to E, okay, whereas the current I2 is from E to B. So what we are going to do is use this formula I1 minus I2, okay, and find all the values. Okay, I1, I2 and I3. Substitute these values over here. Put I1 over here, put I2 over here, and put I3 over here. Okay, uh, I will say what to do for practical. Okay, you are going to use multisim to do the practical. Similarly, for Kirchhoff's voltage law, what you're going to do is do the same steps. Okay, do the same step as it is and find all the three values of I1, I2 and I3. Okay, uh, in this, what you're going to do is assume a random value for voltage. It is not your register number. Assume a random value, 20 volt, 10 ohm. It's your own. Assume your random value. Okay, 20 ohms, 40 ohms, 50 ohms. Sorry, 50 volt. Okay, now do Kirchhoff's current law. That is done as it is done over here. Okay, do as it is. Okay, what will you do is the equation you will get is 20 is equal to 30I1 minus 20I2. Okay, this is will be the first equation. The second equation will be minus 50 will be equivalent to minus 20I1 plus 60I2. This will be the second equation. Solve the two equations and find I1, I2 and I3. Here I3 is nothing but I1 minus I2. Okay, find the three equations. Sorry, solve the two equation and find the three values I1, I2 and I3. Okay, but in the tabular column you note you need to know voltage. What are the voltages V1, V2 and V3? To find this thing, what you need to do is just see here it is a 10 ohm resistance and the current I1 is flowing over here. So to find the voltage 1 V1 over here, we can use V1 is equal to I1 into R. Okay, this is nothing but Ohm's law. So use substitute the I1 value which you found over here into the I1 and use the resistance value as 10 ohm. Okay, find V1. Okay, then substitute the V1 over here. Okay, then similarly for V2, what you need to do is take V2 will be equivalent to I2 into R. Okay, here I2 is the current flowing here. Okay, this is the I2 current. So substitute the I2 current from here and the resistance is nothing but the 40 ohm. Okay, use this resistance over here 40 ohm and find V2, then substitute the V2 value in the tabular column. Okay, next you need to find the voltage 3, which is nothing but V3. To do it, what you need to do is V3 will be equivalent to I3 into R. Okay, here I3 you have found it over here, and the resistance where the I3 current is flowing is nothing but the 20 ohm. So get the value and substitute over here. Okay, then you know the voltage E1, which is nothing but the voltage which you are having here. This is nothing but 20 volt. So substitute the 20 volt over here, and for E2 you are having a 50 volt. So substitute this 50 volt over here. Okay. Then for practical we will be using the multisim online simulation tool. Okay. This is the procedure. Okay. Do you have any doubts in this procedure?
Sir,
Please tell if you have any doubts.
sir,
Yes.
sir, V1 is equal to I1 in the R1 எடுக்கூடாது சார்.
V1 is equal to
I1 இந்த R ன்னு எடுத்தீங்களா சார், அது வந்து R1 ன்னு எடுக்கூடாது சார்.
here the R represents, you say that here's the R. Okay, this R
Yes sir.
represents where this current is flowing. If the current is flowing through the R1 resistance, then here you can take R1. This is our denomination. You can make it as R7 also. Okay, so if you take this R7, then it will be R. Okay, if the current
Okay
is
sir.
through this resistor, you take this resistance value 10 ohm. Okay, that is the main thing. R1 R2 is not the main thing. Okay, if the current is flowing through this resistor, you should use this resistance value. If the current I2 is flowing through this resistor, you should use this resistance value. Okay, if the current is flowing this resistor, you should use this resistance value. Okay, if you want to intimate as R1, you can also do it. You can make it as R2 and you can make it as R3 also. It is not a problem. The basic thing is this one. Okay.
Okay sir. Thank you.
Any other doubts? If you have doubts, you can ask now. Otherwise, we can move to multisim. If you have doubts, please ask. Okay, now let us move to the multisim. Okay, I have given you the procedure how to do. Okay, here the first one is you go to our Moodle one. Okay, go to the experiment 2 verification of Ohm's law and Kirchhoff's law. You click this one. Okay, multisim simulation instructions. Click this one. Okay, I have said what to do. First, assume the voltage sources, a resistance value, and the last three digits as your number. And first, complete the theoretical calculation of Ohm's law and Kirchhoff's law in your lab manual. Okay, this is the manual. Okay, you complete all these things over here. Put the theoretical value first. Okay, complete all the theoretical values first. Okay, this one for Kirchhoff's current law, and this one for Kirchhoff's voltage law, and then for Ohm's law, here is the manual. Okay, there it is. Here it is. Okay, for Kirchhoff's for Ohm's law, here it is. Okay, first do these things. Okay, after completing these things, then go to the mentioned address. Okay, this is the address multisim. Okay, open this one. Wait till it get open. Okay, now it is open. Okay, this is the multisim live. In this multisim live, what you need to do is you need to create an account in the multisim by pressing sign up button. Okay, press this sign up button. I have already an account, so my account is showing here. Okay, so what I do is log out from this. Okay, now what you need to do for freshers, press this sign up button. After you press this sign up button, you need to create an account. Okay, put some names: first name, second name, your role, company. In the role, you can select a student. Here is student. Okay, you can select this one. Okay, if you select student, then it will ask the school. Okay, and put some data over here. Okay, you can put your college mail ID over here. Okay, and create a password. Create a password for your own. Note the password. You have to use this password for sign in purpose. After making all these things, press create account. Okay, if you press this create account, then it will send a verification mail to you. Okay, I will show you. Okay, today morning I have created this thing. You see, at 9:34 a.m. I got a verification mail, and this is the to complete the account registration. Ensure your identity. Please confirm the email address by visiting the link below. Okay, after getting this verification mail, you press this link. Okay, then you will be having this thing. Thanks, your NI account has been confirmed. After this, press continue. Okay, if you press continue, it will go to this page and ask you for password. Use your college mail ID. If you want, you can also use your personal mail ID. It is not a compulsion to use your college mail ID. Okay, you put the typed password. Okay, and press login. Okay, after entering into the account, okay, this is the multisim live account. So, uh, verify your email ID is over. Okay, sign back after verification. I have signed back in. Okay, press create circuit. Okay, here is the create circuit. Press this thing. Okay, this thing will gets open. Now, what you can do is make this as Ohm's law. Okay, after doing it, you know the circuit for Ohm's law. Nothing but you need a battery source. This is the toolbar. You can find all the tools available with the multisim. Okay, this one is the measurement bar. Okay, you can measure voltage and current, voltage reference, etc. And this one is the ground connector. And here you have different types of sources: AC source, DC current source, and a battery source. Okay, some all types of sources will be here. You can see three-phase delta source, thermal noise, and here the passive components are present: resistance, capacitance, inductance, everything is present over here. Here the operational amplifiers are present. Here diodes, different types of diodes like Zener, LED are there. And in transistors, you can see all the available transistors. Okay, NPN transistor, PNP transistors, NMOS, JFET, MOSFETs, everything is here. And there are indicators such as lamps, 8 LED bar, buzzer, etc. And this one is the switches, where you can use the switches to control your circuit. And here are some modeling blocks. Okay, not going deep into this. We will be using only these three things. Okay, first, you know the Ohm's law circuit. First, you need a battery source. It is nothing but this one. Okay, place the battery source here. You can zoom in or zoom up using the mouse button. Okay, if you scroll the mouse in, it will get zoomed. Okay, then you need a resistance. Take the resistance and place it here. Okay, this is nothing but your circuit. This one. Okay, I'm trying to build this circuit. Okay, now connect it. If you the hand comes near the terminal of the battery, then automatically the connection sign will be shown and you can connect this thing like this. Okay, press it once and drag it down and move where you want to go. Okay, you go to the resistance, then press once again. Okay, then the connection is made. Okay, you want to make the connection bigger like this, you can drag it and make this thing. Okay, after doing this, you can assign the voltage values. Can see for the first one, what you have assumed is constant resistance and variable voltage. So take any one of the voltage. Take 10 volt. Okay, I'm going to use 10 volt and a resistance as 10 kilo ohm. Okay, come back to here. You press this thing. Okay, then this one will open. So you can type over here 10 volt and press enter. Okay, the voltage is changed from 5 volt to 10 volt. Then in the resistance, I need 10 kilo ohm. So I am going to type 10k. Okay, and I am going to press enter. Okay, that's all. The resistance value and the voltage values are inserted. Next, what you need to do is you need to measure the current value. Yes, you need to measure the practical current value present in this thing. Okay, to do this one, what you need is a measurement device. Go to this block and select the measurement device, which is the voltage measurement device, current measurement device. So select the current measurement device and place it here. Okay, so after doing this thing, you can simulate the complete circuit by pressing this play button over here. Okay, if you press the play button, the complete thing will start to simulate. Okay, you can see the current value which is flowing over here is nothing but 1 milliamperes. Okay, so similarly you can find other things also. You can stop this one. Okay, you can change the value or slide this one to change the value or enter the value directly like this. It is also possible. Okay, after entering this, you can change this value also and then set play button. Okay, you will get the another current value. Okay, so what you need to do here is after getting these things, you write the values directly over here in your manual. Okay, write the value over here. It says 1 milliampere. For this one, I got 10 milliamperes. For this one, I got 70 milliamperes. Likewise, you write this thing directly. If you verify the theoretical and practical, if you do comparison between these two values, it will be same. Okay, if you do comparison, if you get here 100 milliamperes, then while verifying it in practical also, you will be getting the same 100 milliampere over here. Okay, both will be same. Theoretical and practical will be same in this case. Okay, for this thing also, what you need to do is make a constant voltage value and change the resistance value. Okay, change the resistance value like this. Make it as 200 ohm. Okay, and then set play button. You will get a different value. Okay, set the values which is given over here. Set 10 volt and set 1 kilo ohm and take the reading and put it in the practical. Then set 10 volt, then make it as 2 kilo ohm and get the practical value and put it here. Set 10 kilo ohm, change it as 3 kilo ohm and put the practical value over here. Do this step for all these things. Okay, do this step for all these things. Okay, if you do this thing, you will complete this tabular column. Okay, after completing it, go to Kirchhoff's current law. Okay, for Kirchhoff's current law, you can do the same thing. You need a different circuit. So what you can do is create a new one. Where is this things? Okay, here it is. See, you can save this thing. Press save. Okay, make it as something public or private. Okay, put OK. Okay, after saving, I ask you to make a screenshot. Okay, put print screen and go to paint. Okay, paste it. Okay, and save this paint in a location wherever you want as PNG file. Okay, select PNG in this one. Okay, select PNG and press save. Okay, then go to this thing and create a new file. Okay, now we are going to see Kirchhoff's current law, KCL. Okay, for Kirchhoff's current law, what you need to do is draw this circuit. Draw this circuit in the multisim. Okay, how will you draw? First, take the battery source and another one battery source. Then you need resistances. Then you need another one resistance. You can rotate the resistance by pressing this one. After completing this, what you can do is connect as it is in the circuit. Okay, after the connection is made, go to your manual and find the values. If your register number is 101, use all the values as 101. Okay. Now I am choosing my value is 100 volt. Okay. And here I am choosing 100 ohms. Okay. And here also I am choosing 100 ohms. Here also I am choosing 100 ohms. And here also I am going to choose it as 100 ohms. Sorry, 100 volt. Okay, after choosing everything, for Kirchhoff's current law, what you need to find is I1, I2, and I3. So the current flowing through this branch, current flowing through this branch, and the current flowing through this one. Okay, you need to find these three currents I1, I2, and I3 flowing through the three resistances R1, R2, and R3. Okay, to do it, what you need to do here is go to the measurement section and take the current source. Okay, select it, and this is the path where the current I1 will flow. Okay, so place this thing over here. Then take another one current source, and this is the path where the current I2 will flow. Okay, you can make it in anywhere. Okay, you can place anywhere here or here. Okay, in this complete part, the current I2 will be flowing. You can place here also. Here also the same I2 current will be flowing. Okay, choose any location and place it. Okay, after that, you need to place another probe for I3. Here the current I3 will be flowing. Place it over here. Okay, so what you need to do is you can just press play button, or before this thing, what you do here is select the ground and take the ground over here and put it here and make a connection for the ground. Okay, if you not put the ground, then the current source, that the currents which are measured get varied. Okay, so try to ground a circuit. Okay, in practical you should ground a circuit. Okay, in theoretical it will not be done, but in practical cases you should ground a circuit. So ground the circuit like this. After that you press this play button. Okay, if you press this button, all the values will be shown. The current I1 is 333.33 milliamps, I2 is minus 333.33 milliamps, and the current I3 is 666.67 milliamps. So what you are going to do is note all the values over here. Okay, you get 333.333 milliamperes, and similarly I2 over here, and similarly I3 is 666.66 milliamperes. Okay, note all these values for Kirchhoff's current law. Okay, after noting all these values, take a screenshot with the simulation running. Okay, here you can see the seconds is running. This means the simulation is running. Okay, so take a screenshot when the simulation is running, press print screen and go to paint. Okay, and save the simulation, paste it. Okay, and then save it as 2.png. Okay, select png from here and then select save. Okay, completed. Then what you need to do is you need to do Kirchhoff's voltage law. Okay, for Kirchhoff's voltage law, you can use a different values. Assume a random value by your own. Okay, so stop the simulation. Okay, assume a random value. Okay, assume a random value like this. Okay, uh, that is the random value which you use to solve the sums. Okay, if you use 20 volt, 10 ohms, 20 ohms, 40 ohms, then use the same value here. Okay, use the same value, which is 10 volt, sorry, 20 volt, 10 ohms. Okay, 20 volt, 10 ohms, 20, 40. Here is 20 and here is 40, and here you need to assume 60 volt. Okay, these values are assumed randomly as it is in the circuit diagram that you have assumed. Okay, if you assumed here 20 volt, then same value should be assumed for the simulation also. You should not assume a different value than the theoretical value. Okay, for theoretical value, you have used this theoretical values and find I1, I2 and I3. If you assume a random value in the practical also, you will get a different values over here, then you will not be verified. So use the same I1, I2, I3 values over here, sorry, use the same values over here and get the same practical values. Okay, after doing it, What you need to do is just press the play button. You will get all the current sources, okay, all the current values over here. But in voltage law, you need the voltage V1, V2, and V3. To do it, what you need is stop this thing. Okay, what you need is the voltage. Okay, take this one. You need the voltage across the resistance R1, B1, and take another one voltage reference and press this reference over here. Okay, you can remove the current source. We don't need the current source for voltage verification. So you remove these things. Okay, after this one will give you the voltage across the 10 ohm resistance. Okay, similarly you need to find the voltage across the 2 ohm resistance. Take another current voltage reference. Similarly, you need to find the voltage across the R3 resistance also. So do this thing. Okay, after doing this thing, what you need to do is another step is here. Here in the reference PR4, press this thing. Okay, after pressing this thing, you see here the voltage reference is set to ground. Okay, so the voltmeter is connected between this point and at this point. You have two ends in the voltmeter which will measure the potential difference. Okay, so the voltmeter is connected between the this point and this point. It should not be done like that because we are going to measure the voltage across this resistance. Can see the voltage should be measured across this resistance V1 and across this resistance is V2 and across this resistance is V3. Okay, to do it, what you need to do is go to this thing, press this thing, and select the voltage reference. You will get three references: reference 1, reference 2, and reference 3. Okay, for this one to this one, which is nothing but a reference 1, so select reference 1. And for here, for this resistance, select PR this one and go to ground, that is the voltage reference, and select from this one point to this point, so select, press reference 2. Okay, and similarly for voltage 3, you select this one and you again go to the voltage reference and select here reference 3. Okay, this is the work you need to do over here. After completing this thing, you just press play button. All the voltage values will be shown for you. Okay, very easy. Okay, you can see the voltage across the 10 ohm resistance is 114.29 picovolts, and the voltage across the 40 ohm resistance is minus 40 volt, whereas the voltage across the R3, that is the 20 ohm resistance, is 20 volts. So note these values, which is nothing but 114 point something into picovolt. Then the next value V2 is 20 volts. Note this value over here, 20 volt V2, and the V3 value, sorry, V3 value is 20 volt. V2 value is minus 40 volt. Sorry, this one is not here. Okay, it is minus 40 volt. Okay, then you need to find E1. You need to add V1 plus V2. So add these two things and enter here. Okay, after this thing, you need to add V3 minus V2 and enter here. Okay, that's all. Then take a screenshot, make a print screen, open paint. Okay, open paint, paste this thing, and save this thing as 3.png. Okay, sorry, 3.png. Okay, select this here. Okay, then select save. Okay, after completing these things, the complete simulation steps are over. Your practical is over. The last thing you need to do is go here. You have saved three PNG files: PNG1, second.png, and 3.png. After doing these things, scan your lab manual. Okay, you have written everything here. Okay, you have written everything here: theoretical value, practical value, your calculations, everything will be present over here. So use a cam scanner or similar app to scan your lab manual and convert into manual.pdf. Okay, convert this thing into manual.pdf. Okay, after doing this, you go to this website. Okay, you go to this website. Okay, then this is the PDF joiner website. Go to this website and select upload files. Okay, I have saved these files here. Okay, 1.png, 2.png, 3.png. Select open. Okay, after uploading these three files, again select upload file. Okay, and go to your cam scanner location where you have scanned the PDF file. You go to this thing. Assume this one is the PDF that I scanned. Okay, assume this thing. If you scan a PDF, the original document will be there. Assume this one is the scanned thing, and I am opening this one. Okay, after doing this, what you need to do is press join files. If you press join file, PDF will be save will be open. Okay, in this, put your register number. Okay, put your register number and press save. Okay, after this is downloaded, you will see the PDF files like this. Okay, the image will be here, the next image will be here, and the next image also will be here. Then your lab manual calculation will be here. Okay, your scanned calculation, your scanned tabular column, everything will be here. Okay, what you need to do here is you need to make the screenshot with the simulation running. Okay, you need to run the simulation like this. All the values should be here, and then make the screenshot. Okay, without the values, I don't need the screenshot. So run the simulation, then make the screenshot. Okay, here this one will be your lab manual. Okay, then what you need to do here is come back to our Moodle, come back to our Moodle and select the submission link, experiment 2 submission link. Here, uh, you should submit the PDF file in your register number.pdf. Okay, the attempts allowed is only one. So what you do is check your PDF file. If the PDF is correct, you have completed all the steps. Okay, you need to make three PNG files and one PDF document. Complete these things and convert them into a single PDF file. I have shown you how to convert everything. I have shown you. Do the same similar steps. After that, press the submission link and your submission will be there. Open the uploading submission link and upload this to me. I will get the submitted status over here. I will use this status to validate your marks. Okay, this is the complete procedure for doing the lab experiment for experiment 2. Okay, if you have any doubts, you can ask now.